Hello guys, I'm your friend InsideXO. Today is a lovely day. I want to show you guys how to make a machine learning model for digital recognition. First thing first, I don't want to waste any one of your time, so I just did a copy from some others. Now let's run this model as quickly as possible. Now first we're gonna import the libraries, import Keras, Keras, whatever. Then do some pre-processing to get the training data and test data and all of that. By the way, we have to think for the Kaggle for providing this environment, so we can just doing machine learning or data science at the website. It's quite good, I guess. You don't have to buy a computer which has the GPU inside it. You don't have to. All you have to do is go to Kaggle and start writing. Then we have to normalize and reshape our data. In the end, if you check it out, the first data inside of our Y training is something like this. Now let's visualize our data. You'll see it's something like this. It's all numbers, right? And we can show you the X training, what it looks like. Finally, we are getting to the model building part about this notebook. Here, he just used a sequential model. What we're gonna do is change it to functional API. Oh, no, I'm going to change it using functional API. That's right, let's do it. Oh, trust me, you don't want this. All you need is a Keras library. First, you have to define an input layer by Keras.input. And you have to give it a shape. Here I'm going to use input shape. And the len equal to whatever you. If it's a simple model, you can ignore the len. You don't have to set that. Now we have to define the middle layer. It's also Keras that's convolutional 2D, and it has 32 nodes or neurons inside that layer. I'm going to define the kernel size to 5 times 5. The activation function equal to ReLU. And also we have to give it the inputs layer. Then we have to add another convolutional layer. Middle layer equal to Keras dot convolutional 2D, 64 nodes inside it, and the kernel size equal to 3 times 3. The activation function equal to ReLU. And also we have to give it the last layer that we have defined before. I'm going to add more. The middle layer equal to Keras dot max polling 2D. The port size equal to 2 times 2. And also we have to give this function a parameter, which is the last layer that we have defined before. Okay. And we have to define another layer. We're gonna use the Keras dot dropout, set a parameter of 0.25 and give it the last layer as a parameter. Right, then we have to flatten that layer. So Keras that flatten and also give it the last layer, okay? After that, it's kind of boring. You have to define another dense layer. And that dense layer have 128 loads inside it, or narrows inside of it. And the activation function is ReLU. And we also have to give it a parameter of the last layer, okay? We are almost done. Finally, we have to define the output layer. We're gonna say the outputs equal to Keras that's it's a dense layer, I guess, because yes, it's a dense layer. And the nodes inside it is the number of classes, how many numbers that we want to recognize, how many unique numbers. The activation function equal to softmax because it's a classification problem, so we have to use the softmax activation function. And also we have to give it a parameter of the last layer. Okay, that's good. We have defined all layers using the keras functional API. Now all we need to do is using those layers to build a real model. How to do that? We have to say model equal to keras that model, and we have to give it the inputs. The inputs equal to simply just the inputs, and the outputs equal to the outputs. Okay, that's it. That's our model right now. If we run this, it will say that keras has no attribute to convolutional 2D because, yeah, we get something wrong here. So it turns out that we have to say that keras.layers dot convolutional 2D. So we have to add the layers keywords to every single line of our code. Cool, now we all set up. Let's run it again. And we'll say that it just works fine and didn't have any error that showed up. So let's continue to run this. Yes, compile successful. Now we can train the model. I'm very happy with that kind of speed because it's very quick compared to my own computer. Okay, now it is finished. That from here we can see the accuracy we got is 99%. Okay, it's quite good. Now let's do a real test for that. We have to use this model to protect a real data. Nothing happened. So we would just commit this scene and finish our tutorial here. It turns out after you click the commit button, it will run your notebook again to get the result. But I don't care this because we have already know how to use keras functional API to do a hand digital recognition. Yes, that's enough. So we're happy to see you guys here, and I will meet you again in another video.